Hi students, welcome. In this video we will study about Boyle's law. Okay, so here suppose students, this is the container, this one, and inside this container there is a gas, as you can see, and this gas is loaded with piston, as you can see. There is a temperature gauge, as you can see here, and this is a burner is used to heat this our whole system, and this temperature gauge is used to maintain this temperature at a constant. Okay, so here see, we applied here flame with the help of burner, and we maintain this whole system's temperature constant by using this temperature gauge. Okay, and see here, now in this first condition there is a pressure applied by this piston is P1, and the volume of this gas is V1. So here, or we can see here, we give it a name P, pressure P, and volume V. Okay, in this first condition, so in the our table we will write down here P, P1 is P and V1 is V. Okay, so here now pressure into volume we will get here from this P into V is equal to PV. Okay, in now second condition, see here also we maintain the temperature constant like our first condition by using this burner and temperature gauge arrangement. And now here in this second condition we have applied weight. Okay, weight W. Okay, due to this here pressure is doubled, we can give it a name like that, pressure increased by 1. So here we will give it a pressure 2p. Okay, due to this here volume decreased by 1, so here volume will be v by 2. So here see, in our table in the second condition pressure will be 2p and volume is decreased by 1 again. So here now volume will be v by 2. So here volume decreased, as you can see in the diagram, pressure increased and volume decreased. In diagram you can see this, and from now here pressure into volume 2p into v by 2, from this we will get again pv. Okay, now in third condition we kept here also temperature constant as our first and second condition by using burner and temperature gauge. And now again we have applied here this weight also, again we applied here weight. Due to this volume of this decreased again by again 1, we can see, we can take it. So here now volume, as you can see here, volume decreased in the diagram. So here volume will be v by 3, we give it a name as like this, and pressure is increased, so here we will give it a name by name as 3p. In say, as you have seen, second and third condition, by same amount volume decreased as we increase the pressure. Okay, so here now in this condition pressure will be in third condition 3p, and here volume will be v by 3. So here again pressure into volume 3p into v by 3, we will get pv. Okay, now in fourth condition, here we again applied here pressure, let's give it a name like 4p. Okay, more pressure we have applied, weight we have applied here, so pressure increased and volume decreased by same amount, so here v by 4. So now here by keeping temperature constant, temperature gauge and burner, by using temperature gauge and burner, so here p4 is here now in this condition 4p and v4 is v by 4. So here 4p into v by 4 is equal to again pv. So in all these four conditions, you have seen here this this PV, 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 that is pressure into volume, we get here constant in all four conditions. So here see, now Boyle's law. So here we understood that when pressure increases, volume decreases at constant temperature, vice versa. Like if pressure volume, so here see, pressure is inversely proportional to specific volume, or you can call it as volume is inversely proportional to pressure. So here at constant temperature, okay. So here see, Boyle's law states that when a gas undergoes a process at constant temperature, its specific volume is inversely proportional to absolute pressure. As we have seen here, when pressure increases, volume decreases. As you in the diagram also see, when pressure increases, volume decreases. Pressure increases, volume decreases by same amount at constant temperature. Constant temperature, okay. As in this diagram also, when pressure increases, volume decreases at constant temperature. Now see here, in mathematical form you can write down as specific volume is inversely proportional to pressure, absolute pressure, okay. That is, you can write down as specific volume is proportional to 1 upon absolute pressure, okay. Or you can write down as PV is equal to constant. This is because here see, PV is always constant in every condition, so we have written in here PV is equal to constant by removing this proportionality symbol. Now see here, from our experimental conclusion, here we can write down as P1 V1 is equal to P2 V2 is equal to P3 V3 is equal to P4 V4 up to Pn Vn, that is all conditions. If we further increase the pressure, volume is decreased by same amount, and we will get here PV, which is constant in every condition. So in every process, in graph you can see here, this is state 1, this is state 2, and when we plot these all P1 V1 on this P1 V1 P2 V2 P3 V3 on this PV graph, then we will get here curve like this. This curve is known as rectangular hyperbola curve, and is also called as isotherm. And this whole process, which is happened in constant pressure, and we got result here. When P increases, volume decreases. That is, pressure, absolute pressure is inversely proportional to specific volume, or we can say specific volume is inversely proportional to absolute pressure at constant temperature, and this whole process is called constant temperature process or isothermal process, okay. So students, in this video we have understood about Boyle's law. Thank you students for watching this video. Like, share and comment for this video, and subscribe my channel. Thank you.